Hello, everyone. Good afternoon or good morning, depending on where you are. Let's just take one more minute. A couple of people are still signing in, so I'm going to go on mute for a minute and come back. Okay, hello again. I hope you and your family are safe during these special times, challenging times. But thank you very much for taking the time to join us for this webinar on automation and Rajant's mesh network. You should all be able to see at least the first slide, the entry slide, with the title and my name and Samuel's name. So just quick introductions. My name is Sagar Chandra, and I focus on Latin America with Rajant. And along with me, we have Samuel Brito of SciTech Brazil. SciTech, Samuel wears many hats, but shortly I'll pass the control over to him, and he has kindly agreed to share with us some interesting projects that they have done, they've undertaken and delivered successfully in Brazil. First, a bit of housekeeping. Like most webinars, this webinar is being recorded. It will be available for viewing at a later time for you or your colleagues who may have missed it. We have all the lines muted, except, of course, for a couple of us. And if you have any questions, on your right-hand side, you should see an option, a drop-down that says questions. You can type your questions there, and we will do our best to address all the questions during the end, at the end of the presentation. Also, I have just showing our email addresses, Samuel and my email address. In the event that we don't get to all the questions, or you think of something else after the webinar, feel free to contact any one of us. Okay, looks like we have a good group who has joined. Thank you again for your time. And let's get to the fun part of the webinar. So the mining industry's journey to automation obviously started with some manual tracking, paper tracking. Those days are long gone. Then most of you remember, the introduction and adoption of asset tracking, fleet management, machine guidance, these kind of software, hardware, technology solutions that required a very stable wireless communication. And as long as the wireless communication was working fine, nobody really thought about it. It's only when things started acting up or you had hiccups or loss of data, and then everybody was paying more attention to it. So this is the time that Rajant entered, and we fortunately were able to work with a number of mining operations to improve their use of technology. And if we look at it now, automation at the maximum with technology such as teleoperation, autonomous haulage or other equipment, the use of drones, the need for wireless communication is even stronger. So I'll just take a minute to talk about Rajant. I noticed that there are some attendees who may not know who we are. Every country that you see in blue, that's where we have a customer. Pretty much everywhere there is mining, Rajant has at least a customer, whether it's open pit or underground. For those who may be curious how and why Rajant has grown so successfully, these are the 4 benefits that I usually talk about. And I'll be brief because I know we are all here to hear the real life projects and details of automation. So a couple of the 4 benefits that I feel are important are, first of all, we do not use a central controller. This allows a network to be really fast. And you will hear later when Samuel is presenting how fast our network can be when it comes to sending and receiving video from multiple screens. We always use multiple frequencies antennas. This provides a very high level of availability. The word mesh, when we say we offer kinetic mesh, we have a mesh network. In our case, we mean that every unit, every node can talk to every other node, which is a huge advantage. And then finally, you may look at these boxes and see them as radios or frequencies inside them, but they're actually multiple things in one. So each of the ME4, LX5, ES models, they act as a repeater. They're actually enhancing the coverage. They act as a client. They act as an access point and a switch. So let's get back to what we're here for. When it comes to this automation projects that mines around the world are undertaking, Rajant particularly has been involved in a number of them. There's a coal mine in the US that has been using teleoperation dozer. There's a copper mine in Chile, and Samuel will talk to us about what is happening in Brazil with a number of iron ore mines. So without further delay, I'm going to pass on the control to Samuel, and if he can just introduce himself too. Thank you.
So good evening, everyone, or good morning. Thank you for having you here.
Your slide, Samuel.
Okay.
Perfect.
Okay. Now it's okay. So thank you, everyone, for spending some time with us here to see what Rajant is allowing in the Brazilian mining market. My name is Samuel Brito. I'm responsible for the distribution of Rajant in the mining market and the new business developments for Cytec Brazil. Okay, so I'm going to pass quickly through Cytec and Soltrek Group, a little bit about what we've done with Rajant inside Brazil, and then we're moving forward to the real cases applications. Okay. So about Cytec Brazil. Well, Cytec is a company that was created due to a partnership between Caterpillar and Trimble. And Cytec Brazil is a company that really aims to deliver customized technology solutions to each specific customer operation, okay? We can deliver solutions of technology, monitoring, energy efficiency for the markets of mining, ports, and construction. Okay. So about our group, Cytec is an international company with more than 100 companies over the world. And inside Brazil, it is managed by Soltrek Group, one of the largest Caterpillar dealers, working for more than 70 years, distributing heavy machinery for the Brazilian market. And about, just one moment, please. About our portfolio, in Cytec Brazil, we have some exclusive brands that we can distribute, okay? And as a Cytec, we mainly distribute Trimble technology. In the case of what we normally distribute, we are talking about machine control that allows machines to work with blade control according to embedded 3D project and reaching precisions of around 3 centimeters. Rajant networks providing the InstaMesh protocol to provide unprecedented network availability and reliability. Naval remote controls that this company designs remote controls for heavy machinery, and they can customize to every type of machine. Okay, Propeller, a platform that process images from drone flights and provide useful data, and also allow 3D projects to be designed and created for machine control. So there is a link between Propeller and Trimble. The name of the platform is called Trimble Stratus. And finally, we have the Renter Field Catalyst. It's a mechanical catalyst that allows diesel consumption to be reduced. Okay, so going directly to the main subject about Rajant networks in Brazil. Okay, talking about Rajant in the Brazilian market, we've been working together for around 7 to 8 years now, and it's been a very productive partnership. We reached levels of yearly growth around 85% per year, and that happens mainly because we could improve our customers' operation performance in a very strong way. And about our presence in Brazilian territory, currently we're inside more than 23 operations with more than 1,400 equipment sold. And some of our main customers, mainly we're inside the big mining companies of Brazil, and still working with others. So this list will increase during the rest of this year. Okay, and what really allowed these numbers to happen? The answer is the results of operations using Rajant were greatly increased, and there are some characteristics of Rajant that allowed that to happen. First, because Rajant enables a true power of a real full mesh network, where every equipment really communicates to each other simultaneously in multiple frequencies. This creates a big net of communication with paths in different frequencies, creating redundancy of frequencies and of equipment. So the results are a much more reliable network for mining operations. Also, another detail that allowed Rajant to prove its value inside mining operations is the capacity of automatically adapt to dynamic operations. As we already know, mining demands dynamism, and its network needs to be available during movements, never breaking for handoffs. As the equipment starts to move, it won't lose the many links it has to communicate. Before it loses the old links, it creates new ones as they get closer to other radios. This is why Rajant use the slogan, make, never break. And the effect is the ability to adapt to movement. It is an extremely reliable network, exactly what miners need to their operations. Never worry about networks and communications. So considering the specifics of in the details, the Rajant networks that we spoke before, how is it going to work in a real operation? Exactly as we explained, every equipment that has Rajant inside will talk to the next machine or physical infrastructure, excavators communicating to wheel loaders, then drones, then pickups and trucks. Everything will talk and create a huge network for multiple purposes. Telemetry, dispatch, fatigue monitoring, high precision, video surveillance, voice over IP, everything, and of course, automation. And again, everything working on the same network. So in the Brazilian market, we are using some models of Rajant portfolio. We have many units of the single band radio, which is the JR, the dual band radios, the KM3 and the ME4, working on 2.4 and 5.8 gigahertz. And also we use a lot of the 4-band radio from the LX family, which can also have the 900 megahertz. We use this equipment, these models, according to previous network planning and to what the customer needs to communicate over the network. So moving on to the real examples of automation operating over Rajant networks. The first deployment in Brazil was for an ore stacker and reclaimers operation. These machines, they need to have constant communication, and each time the network had an issue, the whole operation stops. So the time to restart everything was considered as a production loss, and these huge machines, they movemented many tons per hour, so every minute was precious. For that solution, we considered using the 4-band radio to bring equipment and frequency redundancy. And to confirm the increase of performance, and mainly what we could save in production losses if we could deliver a reliable network, we proposed a proof of concept. We tested the current solution from another brand. We checked the profile of network issues, as you can see on the left side of your screen, and the number of production stoppages. So considering the 3 machines, because each line, as you can see, is a network failure, and each color is a machine. So you can see that this operation was really suffering. After we deployed Rajant solution and repeated the same analysis, we could see the second profile of failures on the right side of the screen. But it's important to highlight that every line after Rajant deployment was due to machine maintenance. So it was not a network failure, as the Rajant couldn't receive enough energy to run. It couldn't communicate. So it was not a failure of the network. It's just the radio was not communicated because the machine was shut down. That proof of concept allowed the customer to present this solution inside the corporation and defend it to be deployed over similar operations. They could present that Rajant solution brought a level of 99.9% of availability. This result was so impressive that they started to invite Rajant to new and more exciting challenges. So we started to help mining companies to properly put many autonomous projects to work: autonomous drills, autonomous dozers, and different types of remote cabins. Rajant brought the desired level of latency, throughput for cameras, and all the technical requirements of these solutions to work properly. We will talk more about these types of projects during the presentation, okay? Just me check. Let me just check here. Saga, 1 minute, because I have to cover this part here. 1 second, please.
No problem. I think everybody understands we are all working from a home office, and there are some unexpected challenges sometimes.
Yes, you're right. I'm just checking if the slides are here in the correct order, so we can cover the right subject, okay? So getting back to the real applications of automation, the next project that we supported just updating the slide. Okay, the next project that we supported, it was a very specific type of operation, but also with the same level of importance, because they needed to have a very reliable network. It is the truckless mining, okay? Similar to the stackers and reclaimers operation, this each part of this process needed to communicate to each other in order to properly work on the operation, okay? And if a network failure happened, the whole process would also stop. So after we passed the PLC protocols challenges, we allowed the customer to move from a scenario of some $1 million losses per month to not only 0 losses, but also production capacity increases. And the most recent project for automation operating over Rajant networks was created after Brazil's recent episodes involving mining dams. And we were challenged to design a way that companies would be able to remove material from the mining dams without the presence of humans in dangerous areas, which include not only the dam itself, but also the areas where the material could be projected if a collapse happened. So, including all the technologies inside Scitech Brazil portfolio, we created a remotely controlled system for dam decommissioning operations, where it will be possible to operate heavy machinery inside the dam from a safe distance with precision and productivity. we could deliver this challenging solution because we were working during the last year on a request to apply remote control on an amphibious excavator that worked inside the mining dams, moving the material. For this project, there was a risk that the machine could fall, and so it was needed that the operation was unmanned. The operator would be outside the machine, operating from a safe distance or from an office, seeing the operation through cameras on a monitor or a tablet. As we were really advanced on this solution, we were able to support the remote control for dams. So, considering the dam decommission process, we would need to place not only machines inside the risk area, not one, but many, and of different types: trucks, wheel loaders, excavators, dozers. All these machines will be remotely controlled from a control shelter deployed on a safe area. The red marked area over the picture is the dam area, and this is the area where the trucks and the machines would work. And the blue area is where the safe shelters, the command centers, would be deployed and bring us, in this way, high safety for the operation, okay? And also, in this way, there won't be needed any human interaction inside the risk area. So basically, we would place cameras on the strategic positions of each machine, high precision machine control to allow the machines to operate according to a design project with blade automation, region radios to allow everything to be transmitted in real time to the monitors inside the control shelters, and after all, we would use drones to collect images of the operation in order to upload these images in the platform, analyze and deliver updated data for the operation, and update the 3D project, and then send it back to the machines using the high-performance network. The first technology that we deployed, and it's very important, it's a very important part, is the remote control. We use the remote control that we already had in our portfolio because of the same reason that we choose Navel as a brand to be represented by Cytec. They could customize the remote control for any machine necessary. And we would operate machines up to 1 kilometer away, and we could include the automatic blade control of the high precision systems inside the remote control. And we could operate the machines from a joystick, as you can see, or on a workstation inside the control shelter. And one important achievement for us was the development of a remote control for trucks. We couldn't find this type of technology already assembled or designed in the market, and trucks were a big part of this project. Again, it was only possible because Navel has the ability to adapt and the capacity to customize its technology to different types of machines. As you can see, the truck is being driven from a joystick, and over the cabin you can see all the cameras and the radios assembled and ready to place the machine inside the dam. So after we had all the machines ready to be put to work on our project, the next part would be the infrastructure to put the operators to work remotely. So we needed to provide proper infrastructure, not only to the operators to be inside a safe and ergonomic structure, but that could bring all the technological systems to allow the operation to run remotely, okay? Region communication, workstations, monitors, servers, access control for only authorized personnel, air conditioning systems, generators, no-break systems, video monitoring, and so on. So we designed with our infrastructure partner, the RD Trailers, which are also a region strategic partner for infrastructure. We designed the control shelter that would allow up to 4 machines to be operated inside it, and with everything that was needed to allow the remote operation. So our first unit was created and came into life on the second semester of 2019, and the results were impressive. As you can see, the control shelter had everything that it needed to allow the operation to run from a safe distance using all the Rajant telecommunication structure, all the workstations and the monitors to allow the operators to see what was needed. So over the monitors, the operator could have all the images from the strategic sides of the machine, and also the vision of the top of the shelter to see and check where the machine he was operating was, if it was close to another machine or close to an obstacle or an object. And all these cameras were configured in HD, in high definition. So the network was the core of the project. If the network failed, the whole operation could be compromised because the operators couldn't have the confidence to operate with delay or lack of a proper video transmission. Also, we could improve the solution, bringing more devices that could make the operator experience of operating a heavy machine remotely closer to what he would have inside the machine cabin. So moving forward to the next technology that we applied to our solution, clear that safety was the main point of this project, but also we needed to grant productivity and precision to what was being done by the machine. And that's the great thing of technology. We included Trimble machine control to allow not only the indicative high precision systems and to guide the operators, but also allow the blades of the machines to be automated and move automatically according to the position of the machine inside the operation, 3D project included inside these technologies, okay? Basically, the technology includes sensors and GPS antennas on the machines that receive positioning information of a satellite constellation and the correction of this information from base station. This correction is called RTK, and it's what allows the machine to reach centimeters of precision. It is important to highlight that this correction may be transmitted through the Rajant network, and also the 3D project can be sent over the same network. Again, Rajant was being used for a multi-purpose network. So we used excavators to execute embankment and excavation operations guided by the 3D project. And one of the main objectives is to eliminate the topography team needed on the process. Also, dozers were used for material handling with blade automation, spreading the material in layers evenly, and also eliminating the need of the topography team in the process. Finally, the process would be updated using drones to collect images of the operation. These images could be uploaded to a platform called Trimble Stratus, and this platform can analyze these images and extract many data and useful information from it, and mainly they can use the images to generate the 3D project that was going to be used on the machine control of the machines, and constantly update the operation project and send it back to the machines through the Rajant network in a cyclic process until the end of the decommissioning operation. So basically, the execution will follow a simple but deeply designed. After the machines and the control shelters are assembled and deployed, drones will fly and gather the images, upload to Trimble Stratus platform, process and create the 3D projects, and then send it back to the machines through the Rajant network. In this way, we wouldn't have any human interaction in the risk area, and then we could deliver the first unmanned technology for dam decommissioning process. So these are some of our automation operations running over Rajant networks in Brazilian territory. And we wanted to thank you all for your time and the opportunity to share a little bit of what we're doing here. Here are my contacts, Sagar also. Please feel free to contact us if you have any doubt that you couldn't send to us right now. It was going to be a real pleasure to support you, okay? I think it's time for us to open for questions and answers, isn't it, Sagar?
Yes, yes. Thank you, Samuel. And I apologize for some of the gaps in the communication that we had, but I think we heard Samuel's presentation very well. And for our friends who are joining from Latin America, si ustedes quieren conversar en español o con Samuel en portugués, no hay problema. Nos pueden llamar o enviar un correo. So just a couple of questions that have come and through the system here. Samuel, which breadcrumb model was used in the teleoperation project, the dam reparation project?
Okay, for the dam decommissioning project, we choose the 4-band radio, the LX5, because as I explained, we placed cameras in high definition over the machines that would work inside the dam area. And these cameras would need enough bandwidth to communicate the video properly. So we use the model LX5 2255C, if I'm not wrong, because it had one more 5.8 band, 5.8 frequency band. And of course, we knew that this would be a big challenge. We deployed not only the LX5, but we also deployed a slipstream to increase the capacity of this network.
Okay, Samuel, can you please repeat the model? The system went out as soon as you said LX5.
We used the model LX5 2255C.
Okay, thank you. Marco asked, Marco, for your question, yes, this presentation, this webinar is going to be recorded and will be available on our website in case you missed some things. There are a couple of questions coming in. 1 second from Colombia, and I just scrolled too fast. Give me a second. Jose, 1 second. How big are the operations you support in Brazil in terms of fleet size, Samuel? Roughly, what's the biggest customer and how many breadcrumbs?
Well, our biggest customer in Brazil, it has around 250 radios so far. But there are new operations that they started with a fewer equipment, but they are improving over the time, and they may reach a higher number. Okay.
Okay, thank you. And Jose, and for the rest of the group, with some of the largest mines that we have that I know, there's a copper mine in Peru that is using more than 320 Rajant breadcrumbs. They're using fleet management, machine guidance, and they just put a teleoperated drill on the Rajant network all at the same time. There is a coal mine in Colombia that is at 300 and something, I think it's 325 or 328 breadcrumbs as well. So fleet size of, that's in mining, and outside mining, we have more than 400 Rajant breadcrumbs deployed in one operation. There's another question from Craig here. It's he asks, this is a great use of Rajant technology. What were the biggest obstacles encountered unexpectedly when planning and deploying? Do you want to take that, Samuel? Or?
I think considering the dam project, isn't it?
Yes.
Well, considering the dam project, our biggest challenge, considering the network, was, as I told, the bandwidth that we needed to deliver for a high number of high definition cameras. Considering we have many different types of dams to be decommissioned here in Brazil, but we studied some, and the average size was from 1 kilometer to 1.5 kilometer. And for that, we would consider a number of machines from 20 to 30, and each machine could have up to 6 or 7 high definition cameras. So it was very challenging to design the network to support a video transmission in real time without delays, because if we include a delay, the operator would not have the confidence to still operate the machine. They would be, how can I say, not sure if the machine would be moving too far, too close to an obstacle. So normally they would stop, and this would certainly compromise the productivity of the project. So regarding network, the design to support the high number of cameras was our biggest challenge.
Okay, so thank you for that, Samuel. From my perspective, from projects outside of Brazil, the biggest challenge we typically face, and this really happens in various countries, is there is an understanding of what we expect to have at the mine. Once we arrive at the mine with our partners, we always find some things are not really ready or are completely different. Classic case would be where the antennas are going to get installed, where this particular location will be available for Rajant is no longer available. So fortunately, we have, over the years, by having more than 100 mining operations and installations, we are used to some of these changes as mines are a live operation. But frequency, locations, logistics, things are the ones that usually get us as an unexpected surprise. There's a question here from Linda. Did camera selection make a difference in the delay, or I believe she's asking if we had to ask for specific cameras to be used to allow very, very low latency?
Well, this is a good question. This comes more for the tech team. Maybe I'll need to ask them to check if they try different types of cameras over the time. But we used a camera, but it's not a top brand. It's quite common. We have some uses for domestic needs, but yes, we needed to find a camera that supported the level of video transmission that we wanted. But if we used not this exact type of camera, a bit lower or a bit higher, the big secret of the video transmission was the network. That's why we didn't even think of any other type of network, because we needed to really trust on what we are doing. As I explained, we faced during the tests situations where the operators they said that they were feeling a slight delay, so we needed to check again and reorganize to solve this problem, because they were not satisfied or completely confident to move forward with the operation if they were feeling delays. So the camera, of course, is a point of attention, but the network is the core of the solution. Okay.
And it looks like we lost Samuel for a few seconds. I'll answer it from my perspective as well, Linda. We have worked with remote setups and teleoperation systems from various manufacturers and vendors. So we don't usually control the camera. What we do ask is, in the planning stage, we wish to know the make and model and the specifications, just so that we know what compression logic, what quality they are going to be sending at. But we have, with most of the leading camera manufacturers. There's a question, I just lost it here for a second. Oh, there's a question from Dario. He's saying, can you tell us the coverage radius of each AP to make a mesh? I'll answer that. So there's actually, it depends on what your bandwidth requirements are. I have seen in South America that a Rajant radio can give 2-3 kilometers of coverage. However, if you're talking about sending high definition cameras, or video, then we will not suggest a design that has 3 kilometers using omni antennas, for example. So the general answer that I'll give is 2 kilometers, but that depends on your bandwidth, what you're trying to send. If it's data from a dispatch system, for example, fleet management system, absolutely no problem. If you're talking about fatigue management, where they're sending photos or teleoperation, we definitely would like to do a little bit less. There are a couple of comments thanking Carlos. Thank you for your comment. Beautiful project, he says, and good presentation. Thank you for your comments there. And Brad, so Brad has a couple of questions. Samuel, first he wants you to call him. He's in Australia, but so that's one. The second thing is the combination of Rajant and LTE working together, if we've seen it in the LATAM region. So maybe I'll take this first. So we have seen every case. We have seen mining customers go to LTE and then come back to Rajant. This happened in Australia and has also happened in Peru. We've also seen where some customers are saying, look, I have a Rajant installation and I'm going to put a tower and I make both of them work. The short answer is that yes, we have a solution for someone who is interested in using both. It is not very prevalent, but you have my email address and phone number, or you can contact your local Rajant or representative. But absolutely, we can talk about that. There is just 2 more questions coming in. The truckless operation, what was the latency that was required by the mine?
Well, the truckless operation, it was a requirement that we could meet at a maximum of 8 milliseconds. That's
very aggressive. So hopefully there was no drop in communication when Samuel spoke, but that is 8 milliseconds. In the morning session, we had a webinar, and we had to clarify that because someone heard that as 80 milliseconds. That's not the case. Only 8. The mine wanted 8 milliseconds as a maximum, and we were able to deliver that with Rajant. And I think there's one last that I just saw. Can voice be sent over the Rajant wireless network? Yes, absolutely. We have recently an underground mining operation in Mexico that wanted to not only do voice over IP calls, but they wanted to do video calls. So they wanted someone in the surface office to be able to communicate with someone in a tunnel, and not only using a digital phone, which is fairly easy to connect to a Rajant network, but they wanted to do a video call, and we were successful in demonstrating that. And I think I saw one, I just wrote it down here. Drones, can you just explain what you are doing with drones, or if you haven't done anything with drones in Brazil, Samuel?
Yes. Let me just check if I have this slide here. Yep, here. Here. About drones, we can install a Rajant radio over a drone, and one of the projects that customers asked us to develop is regarding the reestablishment of the network after the blasting operation. That's because when they are about to perform the blasting operation, they have to remove the solar trailers from the area that material can be blasted after the operation. Okay, so as they take all the solar trailers, of course they take all the communication coverage, and the operation would only be able to restart properly when they take all the solar trailers back to its original position, and of course the coverage with it. So to make it faster, they asked if we could put a Rajant radio over drone, so they would fly drones to the position where it was supposed to have the solar trailers, and they could restart the operation before or while they were moving the solar trailers. Considering that they would reduce the loss of productivity due to lack of communication. So it's one of the purposes, but we can
There's a question by Linda, and I apologize. Sorry, Samuel, was there something else?
No, it's just about that.
Okay, there was a question by Linda that I forgot to bring up earlier. She is asking, in your projects where you, when you installed Rajant breadcrumbs without AC power, how were you able to power the units? Can you explain that?
This is a good question. Well, in the whole dam project, we had only one point of electricity that was delivered to us. The rest was with solar panels. So we had many, of course, the machines, they had Rajant breadcrumbs, but we had many solar trailers spread over the dam area. So we could create this previous infrastructure to allow it to work properly. So mostly we had solar trailers, and even inside the shelters, we also had solar panels to provide the electricity needed. Okay.
Perfect. Yeah, Linda, there are various options. You know, the Rajant system, you can of course order it to work with DC power, and as Samuel mentioned, there are a couple of options to be, you know, the solar trailers. There are batteries that can provide a lot number of hours. If you have any questions, absolutely, we can put you in touch with some of our partners who can give you more options. I believe I caught all the questions. If I didn't, I apologize. And I hope you didn't have any trouble listening to Samuel or myself. This webinar is recorded. You have our email addresses, and if nothing else, you always are welcome to visit us on rajant.com. There are lots of case studies, videos, useful information there. Once again, thank you so much for your time. Stay safe, and hope to talk with you in the next webinar.
Thank you, everyone. Have a good rest of the day.